Hello all, I am Praveen Chaurasia from IMS Engineering College, Ghaziabad, affiliated to Dr. APJ Abdul Kalam Technical University, Lucknow. Here I am going to talk about lecture 2 of one of the important topic, that is digital image processing, which is under the curriculum of AKtU syllabus. Now, here I would like to extend the introductory part of digital image processing. Here I am going to discuss about digital image presentation and types of images and their file formats. Okay. So, next shall I just having the digital image. In previous lecture I have talked about image. Here I am going to talk about digital image. Why it is called digital? So, that thing we have to identify, and that function we have already talked about in lecture 1. So, that is the function which is actually we are taking the matrix form of image aspect, and that image is actually we are considering as a function of 2 dimensional, and where x and y are the spatial coordinates, and the amplitude of that function is actually the intensity, or we can say gray level. So, by using smallest portion, if we talk about that is the image, and if you classify that image in this direction x direction as well as in y direction. So, that smallest portion is known as pixel. So, here that pixel we have to identify what it is. So, the smallest element of that digital image is nothing but it is pixel, okay. And it can be from 1 bit to 32 bits of binary code, and we can say we will identify how the bit is actually making the impact on the image. So, for 1 bit binary code, what is the image outcome will be there. If 2 bit binary code if you use, then what is the outcome of image, that thing we will talk about in the next slide. And so many format we have to use to recognize each and every pixel. So, one of the standard phenomena is we can take here, that is red, green, blue RGB format. Another that is CMYK, that format we can also you can use, that is the another image capturing standard, that is cyan, magenta, yellow and black. And if you enhance the pixel, then we can say resolution of the image is also have some changes. Now, see, if we talk about bitwise image, then if you taking the 1 bit binary code for each and every pixel, then that your image is look like this one. If you have 2 bit binary code of pixel, then each and every pixel are having 2 binary code, 2 bit of binary code, then it will enhance and it will look like much better. After that, if you take the 24 bit of binary code for each and every pixel, then it will more recognizable, right. And that pixel depth here is has to be taken into the account. Now, if we talk about the number of bits to store each pixel, then it is actually the pixel bit. If depth is greater, then more number of colors you have to observe. Now, you can also observe here in this phenomena, you can also observe the pixel depth, right. If we are increasing the greater depth of the pixel, then the size of the file is also get enhanced, okay. So, that is sometimes it is more, we can say drawback of that type of image. If we talk about the monochrome image, then you can use 1 bit of pixel of each pixel, 1 bit of binary code. So, there is only 2 color is there, that is black or it can be white. Now, if we talk about gray scale, then you can use 16,256 color here based on the different gray level. Now, if you observe the true color, or we can say actual color of the image, then you have to at least take the 24 bit binary code for each and every pixel. Here you can observe here this one, that is the complete image of this portion. So, you can observe all the color here. So, that is on the 224 bit code for each and every pixel. If you talk about image function and you are dealing with image processing, then your image should be in a function form, by which you can operate, by which you can add some of the function. After that the processed image came at the output end. So, each and every pixel has to be recognizable. So, see, if we have x axis here and y axis here, and for one particular image which I have also talked about in the previous lecture, then m number of pixel you can observe here an x axis, and after that n number of pixel you can observe at the portion on that portion, right. Now, see this n number of pixel on the y axis and m number of pixel on the x axis. So, you can observe each and every pixel at that end. So, if you have m number of x axis and n number of pixel on the y axis, then you can say 1 cross 1 is nothing but this one. This pixel is representing 1 f 1 of 1. Okay. So, whatever the intensity, whatever the value of that particular pixel, then it has the value of that particular function. Similarly, if you talk about f of 2 of 2, so that portion came into the picture, first, second and first and second on that particular portion. So, that portion is actually the f of 2 comma 2. So, that is the location of each and every pixel. So, it can identify each and every location of the pixel by which we have to process further and get enhanced image or restored image. Okay. So, now if we talk about label of these images, so label can be defined in this form, and you have to use intensity interval that is from 0 to L minus 1, and L is nothing but it is 2 raised to power k, where k is nothing but it is the number of label you are observing. So, if you see the total size of that image, the number of bits you can identify that m cross n cross k. If m is equal to n, or you are taking the square image, then the entire table is you can observe here. See, if n is 32 and you are taking 32 cross 32 image, then your label is up to what 1024 label, it can be easily you can identify. If you have L is equal to 4, then it will become 2048 and so on. So, if n is increasing, your size is also get increased here. Okay. So, by using this table you can identify the number of bits b, or you can say size of that particular image. Now, if we talk about resolution, then it can be identified using spatial and intensity resolution. So, two types of resolution you can identify here. If you talk about the spatial resolution, so that is under the x and y direction. So, each and every dot is having different kind of location. So, dots per inch is actually stated the lines pairs per unit distance. So, with respect to distance you can identify the spatial resolution. So, if you talk about the unit of spatial resolution, then it is dpi. So, at where the each and every dot with respect to distance is increased, then you are taking, you can identify spatial resolution you are enhancing. If it is degrading, then you can say spatial resolution is decreases, right. If you talk about the another kind of resolution, that is intensity resolution, then total number of bits is used for one particular pixel, that is actually come into the picture. Now, change in intensity level is present inside the intensity resolution, and by using number of bits you can observe the intensity type of resolution. By using the picture, I will also talk about how we can identify intensity resolution and spatial resolution, that is also present in a next slide. So, see, if we take the picture of these 4 designs, so that is the A portion, this is the second image. So, B legend is there, and this is the C image, third image is this, and the fourth one is this one. Okay. So, if we observe the typical effect of reducing spatial resolution, and that entire images is under the, we are taking the image from Vanderbilt University lab. So, I am giving the courtesy to him, and we are observing the spatial resolution portion. So, for the first image is more clear than other one. So, you can observe the 1250 depth per inch, dots per inch we are taking here. So, that is 1250 dpi image we are observing in this first image. For the second one, we are having 300 dpi. So, you can observe that image is not that much clear, it is degraded one. Okay. And if you talk about the another image, that is the third image. So, here you can observe 150 dpi, and for the least enhanced image, that is 72 dpi. So, here you can say, you can also observe some of the portion is also missing. See, that portion is not that much clear to recognize what is the actually point is locating. So, that portion is actually missing in this. So, if you are making lower dpi, or you can say lower spatial resolution, then your image is actually degraded. Okay. So, if you have higher image spatial resolution, then you can say you have complete image. Okay. And more of the information you can capture from that particular image. Now, see, here I am talking about the another resolution, that is called intensity resolution, and that is also the courtesy by Radiology and Radiological Science and Vanderbilt University. Okay. So, that is the first image I would like to, I will tell about it. That is the second image, and this one the third image, and this is the fourth image we will talk about. Now, see, if you talk about the first image, then we have 452 cross 374. So, m value is 452 and n value is 374 for first image. So, here we are taking the level, that is 256 level. So, 256 level. So, if you observe the k value, then it is around 6 to 8. Okay. And if you are decreasing that level, then it will look like this one. So, here m and n value are fixed, you are not changing the spatial resolution, here you are changing the intensity level. Okay. So, that is under the intensity level recognizer. So, by which you can identify the intensity resolution recognizer. So, L is nothing but it is the gray level identifier. Okay. So, each and every image are having same m and n value. See, 452, 374 in a second image, third one is also 452, 374. Here we are again decreasing the level, that is nothing but it is the intensity level, and for the fourth one it is also we are observing lesser number of levels. So, here we are decreasing the level and you can say the decreasing of intensity level will also impact your image, that is not that much observable. Okay. So, that is all about the intensity level and intensity resolution and spatial resolution. Okay. Now, if we talk about the another topic of image introductory part, that is the types of images files, and here you can observe many number of files you can observe. So, basically if we talk about, if you classify the image, then we have two type of images, that is by the property of that image. First one is bitmap, that is nothing but it is called the raster image, and another one is vector graphics. So, these two types of image we can observe. So, what is the bitmap raster images? So, here it is nothing but it is the collection of dots, and you can also observe these kind of image in so many formats. So, here I am just giving the brief idea of the image file format. Okay. So, your PC might have an image in terms of GIF, JPG, PDF, PNG, PPT and TIFF format. So, these nothing but these are called the image file format. So, before considering the image file format, we have to understand what is the bitmap file image, and that is nothing but it is the collection of dots. Each pixel hold 1, 8, 24 bit of color information. How a bit of color information get changed the image, that thing we have already covered in previous slide. Resolution is fixed, that part is also present in a, that is the speciality of bitmap image. Resolution is always fixed, whether it should be a spatial resolution or we can say intensity resolution. So, that should be the fixed, that we cannot change in the bitmap type of image for resolution purpose. So, it is best for photographic quality image for printing and scanning. And how we can recognize such type of bitmap file? Then that is these are the extensions of these files. So, .bmp if it is present, .gif it is present, if it is PNG form, if it is in JPEG form, if it is in TIFF form, then you can identify these file are the bitmap images type of file. Okay. So, that is the first classification we have identified here related to image. Now, if you talk about the another file another type, another classification of image, that is called vector graphics. So, here you may observe it is nothing but it is mathematical instructions, based on mathematical instructions, basically defined by shapes and lines, not resolution dependent. So, you can change the resolution, it might be infinitely scalable. How we can identify these kind of files? So, it might have the extension, that is .svg scalable vector graphics, .ai Adobe Illustrator, .wmf Windows meta file. So, these kind of extension, if one file might have, then you can say that file is belongs to the vector graphics. Okay. And meta file graphics is also another type of the image, then it is nothing but it is the combination of bitmap and vector type of image, and the extension is nothing but .cgm. Okay. That is not, that is the full form of CGM, that is combined graphics meta file. So, these three types we can identify for the purpose of image. So, we can say two types of image are there basically, and the third one is the combination of above two. Okay. So, now if we talk about the file format, we have identified the classification of image. Okay. And after that the file format comes into the picture. So, here I am talking about the first file format, that is the JPEG. So, joint photographic expert group, that is the full form of JPEG, and what is the actual procedure to identify the JPEG, or we can say what is the actual purpose to generate the JPEG file, we are not covering here. We are just taking the brief idea of JPEG file and why it is useful and which kind of application of that JPEG file is there, that part we have to cover here. Okay. So, now you can say you may observe the most applications and browser digital cameras can use JPEG file. Why it is so? Because it has the more compression ratio. Now, what is the compression ratio? Why we are taking the compression word here? Because if you enhance the image, then more number of bit is required. So, we can say more number of size is also get increased. So, if size is increases, then your web page is too much bulky. So, if your web page is too much bulky, then it will take some more time to load that type of value or load your particular website. So, your image should be compressed in a manner, okay, so that will take a smaller time to load, to get completely loaded on that particular bandwidth. Okay. So, speed, if you want to speed up your website or pages, then you have to use some of that type of image that is not that much bulky. So, size should be reduced there. So, you have to use the compression algorithm to get compress of that image. So, here if you talk about the compression algorithm, one of the compression algorithm you can choose for that particular JPEG. Here I am not talking about that algorithm. So, now the 10:1 or 20:1 compression ratio we can identify, or we can say if one JPEG, if one actual file are having 20 MB size, then if the compression ratio is 10:1, then it is actually, it will generate the 2 MB file. Okay. So, that is the meaning of compression ratio. So, it will reduce up to the 10 divided by 10 of that particular file. So, your 20 MB file get reduced in just a 2 MB file. Okay. So, it will mount on any kind of web page, and it is fasterly you can say it will be loaded, and it is actually the lossy compression, it will use lossy compression techniques. Now, if we talk about the another kind of file format, that is called GIF format, that is the graphics interchange format. It has the it is the combination of number of images. So, you can say, you can observe this image, it will, your earth is rotating. So, you can make the GIF image of that kind of image. Now, here if you talk about the lossless compression algorithm, so LGW kind of algorithm, we will also talk about this thing in later, in next lecture. You less space, less loading time it is required. Then one of the important aspect is there, that is called interlaced and non interlaced. Support, it can support animated format. So, that is also the GIF property, and the extension is .gif. So, that is also the under the bitmap file. Now, if we talk about PNG, another kind of file format, that is the portable network graphics. So, it is why it is generated, because it has the legal problem in a GIF. .gif patent has been expired. After that, we have to use the PNG file. So, here this one is also the lossless compression, and transparency, that is the alpha channel we have to use. If you talk about the CMYA format, then alpha channel is also the addition of these 3 color. No animation supported. In PNG file, animation is not supported. Interlacing is better one as compared to previous GIF file format. We can use Adam 7 algorithm, and the 24-bit RGB, that is belongs to the true color, that thing you can also identify in. And now, in a nutshell, you can take the comparison of all the JPG, GIF, PNG and TIF file comparison bitwise. So, here we are taking 24-bit, and compression algorithm is actually lossy for JPG. So, and if you have the complete image, then you can go towards the PNG and TIF that has the lossless technique algorithm for comparison. Now, for common use web graphics, buttons, icons, replacement, professional photos, you can load for TIF file only. Now, these are the references we have used in entire lecture. So, first one is as usual for Rafael C. Gonzalez, that is your textbook, and for second, that is your reference book, and after the third and fourth, we are also taking for the purpose of comparative analysis, compression techniques and image compression techniques. Thank you all.